Hi, class. This is an introduction to the elementary statistics course and um, some information about those first few chapters that are going to be on that first exam. So, one thing I want you to note is that this page right here is the sixth edition of Mario Triola's Essentials of Statistics, and the videos aren't necessarily about or using this particular textbook all the time. We've had several different editions and different authors, and um, I'm using some videos from previous semesters and then trying to add to that. So it's always an evolving process, and remember that the content though stays the same. The book might look a little different from yours, again because it might be a different edition or author, but the statistical content and the information really is all exactly the same. So we're going to go ahead and get started. And again, this video is hopefully will help you understand uh, the information. And I'm not a professional video maker. Again, I'm a classroom teacher and just doing the online because of the present circumstances. And but what I'm looking for here is we're going to get to. So hopefully I'll get better as we go making these videos in this particular book. But in chapter one, it kind of just gives a brief introduction about statistics, and it is a important course, one of the most important courses that you'll take at the college level. And there's been a real explosion of the use of statistics over recent years. In fact, some people speculate that about 90% of all statistics in the entire world have been the data that we have now presently. All of that 90% has been collected in the last 10 years. So that's an incredible number right there. And so it has always been around in some senses, but never really started to grow until computers actually came into play. And so in the 1970s and 80s, it grew somewhat, and we started to see more people being required to take statistics. And it seems like nowadays, though, that everybody to get a degree at a lot of universities, everybody has to take at least one statistics course. So in general, what is statistics? And it's a communications course, actually. It helps you understand how to communicate effectively with information involving numbers. It's not a mathematics class, even though it's typically taught in math departments, and it's um, usually you get math credit for it at the college level. But that's because all universities and colleges don't have a separate statistics department to be able to offer lots and lots of courses, and we're in that process of changing over a lot of people's thought processes and degrees and programs and so on. So eventually, I think that statistics departments will be just as popular or commonplace as mathematics departments are at all colleges and universities. But statistics, it says here, is the science of planning, experimenting, obtaining data, organizing, summarizing, presenting, analyzing, interpreting those data, and then drawing conclusions. And so basically, if I can, you know, simplify that somewhat, is that when you talk about statistics, he starts out here data, and you really are have intentions of working with data. So he said it's the science of experiments and obtaining data. So when you work with making decisions, you typically would like to make the best possible decisions in whatever you're dealing with. And that's why statistics is so popular, because this applies to absolutely everything and anything. And so you want to make a good decision. A lot of times, if you go out and collect some data and you do everything properly, uh, you can find, what are the best decisions that you can make in any given situation. And again, that's a lot of work. It's why there's a lot of statistics courses out there. There's over 100 different types of statistics courses out there at colleges and universities. It's a very, very extremely broad field, and it continues to grow. And the idea is that we're working with data. We're trying to use that data to help us understand things better, how, better to make decisions, how to move forward, answer questions, test theories, and lots of things like that. So basically, we get that data, and then you got to organize it. So you organize it, and then we see what we got. And again, he talks about summarizing or interpreting what's there, presenting it, and then it says drawing some conclusions, maybe making some inferences. So what I want to do is just pull this. Let me see if I can get this off of here. Um, and I'm going to write on this board, but I want to clarify that information just a little bit more. And so, so we have statistics, and typically we look at it. There's two kind of categories. Okay, so over here we call it descriptive statistics, and over here inferential. Okay, so when we have an idea or something that maybe we want to collect some data on, we really need to define what they call the population. So the definition in the book says population. That's just all the elements here to being studied. So that's great, but it doesn't really give you the picture of what's going on. What we need is to have a well-defined path, and we really need to understand exactly what we're trying to find. So population has to be well defined. So it's not something you can just say, well, my population is going to be everybody in the United States. So I want to try to get some information about something in the United States. And, what are people's favorite foods, or what are people's favorite fast foods throughout the United States? And so my population, and then it's not quite that easy, even though it sounds like that's reasonable, but there's a lot more to it, because you have to decide, well, what are you trying to find about these fast food stores? Why are you trying to find out which ones are the most popular? Is this something to do with supply and demand? Is it a business decision? Are we trying to get into the marketplace? Is there an opportunity for a new type of field within fast food? Um, when you saw things like Chipotle that broke into the fast food market, and which everybody thought was kind of not possible years ago with McDonald's and Burger Kings and Wendy's and all that. And that was pretty much taking up, 95% of the market. And then Subway broke into it. And then it was like, well, this is pretty much, and then all of a sudden you see now these other chains. So, they obviously saw something that was there. And believe me, they just didn't make it up and go forward without collecting lots and lots of data and seeing if that was going to be available to them, and then they moved forward. So population, uh, we really need to um, have it well defined, and then what happens after that, though, this is a very important idea in statistics, is that you define a population, and then you want to collect data from that population. But the reality of it is that you rarely can ever get all the information that you would like to from the population. So then what you have to do is take and get data from part of the population or a sample. So a sample is a subset or a part of a population. So that sample we're going to use. We can always get a sample. We can't ever, if ever, get, and I can't say never because, again, we can in things like Major League Baseball. We get all of the data from all of the players, and everything is collected from every single player in the league. So sports, things like that, professional sports, and they do get population data, but 99% of the time out there when you get out and you collect data, it's not a population, it's a sample. Okay, again, we're part of. So what we need to be able to do then is talk about the differences in results between the two. So we break statistics up in terms of, are we talking about sample data or descriptive statistics? Okay. So these are things that describe a sample. So are we talking about the sample or are we talking about the population? Okay, now inferential statistics, things that describe a population. Okay, now, and the big thing to remember about the difference between the two is that, again, most of the time when you go out and collect a sample, you're going to have to organize it and get it together. And they said that, statistics is about collecting data, organizing data, then interpreting that data. And um, when you work with a sample, you're not trying to make inferences or say, I think this is what this is saying. I think this is what we got. Basically, you're being very descriptive and saying, this is what I came up with. This is what was in my sample. And then we take that sample information and we try to describe the population by use of inferential statistics. So we have descriptive statistics, we have methods of coming up with ways and things to describe a sample, and we also have ways of coming up with things about a population. The big difference is descriptive statistics should not have any air in them because you're just saying this is exactly what I got. I'm not trying to say that it is exactly what I wanted or that it is really what is going to help me understand the population. All we're saying is that here's what we got. And then we use statistical techniques to help us draw inferences and conclusions about the population with confidence. So that's the difference. We can collect data and say, this is what it's saying about a population. But if we don't have certain techniques, we're just taking a guess. We're basically really just guessing, okay? So what inferential statistics allows us to do is to provide certainties or probabilities. Remember that statistics is probabilistic modeling. So we can state or make claims about populations with a certain amount of confidence. And that's the key than just going out collecting data and making up some conclusions about it and saying this is what it's stating. So again, the first part of the course, the very first unit of this course is all about descriptive statistics. And then the rest of the course is all about inferential statistics. Okay. So again, I'm going to be kind of jumping back and forth. I'm going to leave that up there and go forward here. And see. what we got. Okay. And again, you guys can read the book. I'm not going to try to go in detail and explain. A lot of this is written very well. I'm trying to put together everything. Let's see. We want to get into the now in section 1.2, types of data is on the other video. So you need to watch the other video on types of variables. That's section 1.2. And then we are going to go over to page 25. There we go. Okay. Okay. Now, so collecting data, obviously, that's what statistics is, involves. It's a major part of statistics. We got to go out there and get that data, and hopefully we have it well defined. And we know what we want because we know basically, what it's going to tell us kind of after we get that data collected. But the one thing we have to understand is that just collecting any data doesn't mean it's going to help you make good decisions. And that's one of the problems. A lot of times people will read about a study and they'll say, wow, this study, look, they collected this data. And they come up with all these really neat things. And a lot of it is just again, guesses. They have no idea what they're really talking about. So what do we need? Well, we need what we refer to as a representative sample. A representative sample is one where the sample characteristics that we're studying that is of concern, those characteristics in the sample are basically the same that are in the population. So then if we talk about the sample, then we feel pretty good that we're also talking basically about the entire population. So we need a representative sample. And then here on page 27, how do you get a representative sample? Well, there's not that many acceptable methods. So we're going to talk about those and see what we can come up with here. But the first one is this simple random sample. So a random sample means every element in the population has an equally likely chance of being selected for the sample. Okay, so again, we have a population and we have to select so that every element in the population has the same chance of being selected. So it sounds reasonable. Now, how do we do that? Well, one method is to first, if you can number all your elements, 1 through whatever. If you have a small sample, you got 30 data values, you could number them 1 through 30. And then you can use a random number generator. Your calculator, the TI-84, has a random number generator on it. It tells you which numbers out of those 30 to pick and use in your sample. Okay. Now you can have a large population and still be able to use this method because it might sound like, wow, what if I'm talking about like the whole United States? How can I number, whatever there is, 250 million people or so. I'm not even sure how many people are in the United States, but there's hundreds of millions of people. How do we could possibly? Well, actually, we do. Supposedly, everybody that lives in the United States has a Social Security number. So everybody's already numbered. So you can just randomly select Social Security numbers if you wanted to do that. Also, you could say, well, I'm just interested in adults and typically at least 16 and over. And you could say, well, hey, everybody, a lot of people have driver's license. And even though it's not everybody, but, maybe 90, 95%, I'm guessing, has a driver's license. So you could use driver's license numbers. uh, it could be different things that we've already have numbers out there, and we could try to pattern our study around that. So a computer random number generator, we would write a little program, tell it how many people are in the population, how many we want to be in the sample. Your TI-84 will do that very easily, and you can come up with a nice representative sample. It works very well, actually. Now, another method that works is this systematic sample. Here they have listed. Systematic sample is like using a computer random number generator. You number all your elements first. So let's say at the college, we do this at the college, and we have around 9,000 students, and you think, wow, it's a lot of students. Can I possibly number? Well, yeah, everybody already has a number. If you go to the college, you have a number. And so basically what you can do is put them in order and then take every what they call kth element off the list. Like they're showing here, third person, the sixth, the ninth, the 12th, the 15th, the 18th, and so on and so on. Or if you didn't want that big of a sample, you could say, I'll take every 10th person, every 10th person number 10, person number 20, person number 30, person number 40, and so on, and do that. So systematic sampling is actually empirically tested to be the best sampling method. So it's nice and easy. Again, if things are numbered, okay, so um, this third one here, convenience sample, is not a good method for collecting data. It is not a representative method of collecting data. Okay, a lot of people will just collect data that's easy to get. Could be on the internet. They could be standing over at the front door by the mall as people walk in and out, or at some place where you eat fast food. I've seen people stand out there and ask people questions. That's convenience sampling, even though they try to sometimes mask it as being representative. Typically, it's not. Now, so let's jump down here to these other two. Stratified sampling is when you group first, like they're showing here. I group men and women, so I have two different groups. Then I select, now they're showing here, the same characteristics randomly sample with those. Oh, sorry, I just said cluster, I meant stratified. Or whatever I said, but stratified sampling right here. So stratified means to group here, and they grouped men and women, and then you randomly select from each of those groups. So you set it up because there's a reason why you want maybe equal representation in your study, men and women. So you equally take from each of these groups. And there may be a reason for you to not want equal representation. For example, at the college I'm at, 65% of the students are female. So in your sample, you may want 65% of the women, of the sample being women, and 35% being men. So what you do then is you sample that way. Okay, you take 65%, right? 35% men. And so that's used a lot too. But in this case, every group has representation. Okay. Now, with cluster sampling, you'll notice it also says group here. So it says group here also. It says stratified, you create groups. Cluster, you create groups. So clusters are groups. Now, what's the difference between these two methods? Well, stratified, you select from every single group. So maybe you're talking about counties and in a state, and there's like 30 different counties. you would select from every single one of those counties, randomly select from those. That's stratified. But maybe in that particular state, 30 counties is too much. You just don't have time, you don't have the money, you don't think you really need to select from every county. Then what you do is you randomly select some of those 30 counties. So that's cluster sampling using a random method to only select some of those 30 counties. Okay. And that's typically about all in terms of, you'll see here, again, they kind of put that together, but in terms of sampling, that's really all you need to know for this course. There's a lot more to it, but the there's entire courses on sampling if you're really involved in it. If you get a job and you're collecting data for someone, then you would actually probably have to take some courses on how to collect different types of samples and so on. So that's really about it for uh, that first chapter, chapter 1. So we're going to stop there, and then um, you have the other video to look at, section on types of data and variables, types of variables. Uh, and then we'll have a separate video on the next chapter.